Hi everyone, glad to see you here despite 9 a.m. So my name is Piotr Betkier and I'm passionate about how things break. New languages, new technologies are fine, but I want things to just work, so I want to know what can go wrong. So I've seen already a bunch of failures in my programmer's life, and in particular right now at Allegro, where we have a system of like 400 microservices, yeah, things can go wrong in really many ways. So at Allegro, we noticed some common scenarios, some common patterns in how apps may become unstable. And about a year ago, we documented them for everybody in the company to prevent these occurring failures from happening again. Some of it got published on our tech blog, allegro.tech. And now I want to share with you some of these experiences. So I hope that it's going to be useful for you in making your apps rock solid, basically so that they can earn money like they should, right? So what we're going to do is we're going to build an application based on Spring Boot. Perhaps let's call it a microservice because we are at a conference, right? And we're going to see how it breaks in production with no apparent reason. These are not going to be like business logic errors, like a buggy if statement, but our application just suddenly breaking after weeks of running smoothly. So we're going to find out what happened and how to fix these vulnerabilities. So let's imagine we're working in a company called shiny.io. It's an e-commerce site. It's a quite large company, and we are working on a new page, on a new feature. This new feature will be called Showcase, and what it does is it's going to be like a gallery of all the most attractive, like fancy offers we have in our system, so that a person can go into this site, into this page, and look at the offers and like spontaneously buy something because he really liked or she really liked the item. So we're working in a large company, let's imagine, so we're not the only team building this feature. So our part in this is going to be to select the offers that should appear on this page. So from all the offers in our system that are being created, we want to select these most attractive offers to be displayed. That's our task. So we're going to build a Selector service. This Selector service is going to get some offers. So, of course, if you are an e-commerce site, then we have offers in our domain. Offers are very important. So offers have multiple fields, like title, description, price, things like that. But for us, the most important will be ID and image URL, because that's how we were going to decide if the offer is attractive or not by checking the image. So we're going to get notified by some other application about offers created in our system. So we're going to expose some REST API. And then once we get the offer, what we're going to do is get the image URL and send it to a different service, image scoring service. It's a service written by some other team. It has some deep learning, AI, complex stuff that is able to say how attractive an image would be for a human. And this service is going to return a score from on a range of from 0 to 1, which says how attractive this image is. So if the image is attractive, then we want to save it to our storage, to our database, so that we can later display it on our page. And if it's not attractive, then we just don't do anything. We drop this offer. So let's look at some code. I have it on my slides. So this is an offer. It has a lot of fields, and most importantly, ID and image URL. Yeah. Then we have our controller. It's a controller from Spring, based on Spring MVC. So yeah, basically it gets an offer as a JSON, and it gets deserialized into an offer object, and then we are going to process it. So we are going to give it to our offer processor, and once the processing is finished, then we're going to return 200 OK to our client. So simple stuff. And offer processor, what it does, it gets an offer. It asks image scoring service for a score for this image via scoring client. And we get the score. And if the score is higher than some threshold, we say that, yeah, this image is attractive. It should appear on our page. So we're going to save it to our repository with the score. And the last class that I want to show you, the last piece of code, is scoring service client. So basically, we get the image URL. We have a REST template. We make a GET request to our image scoring service with the image URL as a parameter. And what we get is a score response, which we extract, and we return as double. So pretty simple service. So let's imagine it's working in 2 instances, and Selector 1 apps internal, Selector 2 apps internal. That are the host names, and it's running on production for weeks. Everything is fine, and there are no problems with it. But suddenly, out of the blue, we get an alert that this first instance is not responding. So what happened? What would you do? Any ideas? What would you do to discover what's happened? Huh? Okay, that's one idea. But it doesn't solve it. As we will see, it won't solve the problem. So let's check what's happening. From our laptop, let's make a CURL to this application and see if it's really not responding, or maybe it's something with our monitoring. Well, yeah, okay, we are hanging on this connection. We don't get any data, so yeah, it's not responding. All right, but maybe our host just disappeared from the network. It may happen. So let's try. Yeah, okay, we ping our host, and it's fine. We get the response it's pretty fast. So it's not the problem. So it should be a problem with the application itself running on this host. Right, so imagine we're not running on some managed environment like Marathon Mesos or Kubernetes. Let's say we have our own machines, virtual machines. So let's SSH onto this machine and check what's happening. And while we are SSHing, we get an alert that the second instance is also down. Well, that's bad. All right, so we are on this host. So what can we do while we are on the host to check why the application is not responding? Okay, check if it's running. Yeah, okay. All right, let's check the logs. Well, the logs are fine. I mean, we don't see any exceptions if that's what we wanted to see. Well, basically, it seems like it should be okay. What can you do? Perhaps there's something going on this host that prevents our application from getting their CPU, for example. So let's check. Like make top. Yeah, what we see is our machine is actually not doing anything. It's mostly idle. It's not doing anything. So yeah, what can go wrong? It's probably not garbage collector because CPU is like very, very low CPU usage. So what we can do is check the process ID of our application first. So using this tool JPS that we have on our machines, if we have JDK installed, we check all the process IDs of all the Java apps running on our machine. So we have, of course, the JPS tool because it's Java, and this Selector app. So now what we're trying to do is see what our threads are doing. So we have a tool called JStack where we can see what our threads in our application are busy doing. So maybe we can see what they are so busy doing. So what we see here, I don't know if you can read it well. So I will highlight the important part is the thread dump. All the threads, the stack of all the threads in our application. And what you see here is that our HTTP thread, our thread from Tomcat, it's waiting for data on some socket. Basically, it tries to read the data, and it reads this data. And as we can see, it's reading data from our scoring service client. So it's scoring service client, and it's busy waiting for data on a socket from REST template. And if we see closer, we see that all the threads, all the HTTP threads we have in our application are doing just that. They're just waiting on a socket and just reading the data. So, yeah. So steps for fixing problems in productions, I would say there are 3 steps: like discovering what's wrong, getting it working as soon as possible, and then thinking about long-term solutions, how to prevent these things from happening again, like systematically, so we don't get these kind of errors in the future in some different parts of code. So what's wrong here is that, well, we assume that network is stable, and if we ask for data, we for sure must get it. So the problem is that network is, in fact, may become unstable, and if we ask for data, we may not receive it. So our problem was that we configured our scoring service client in a simple way, like we would do in some Hello World app, just creating new REST template. And what it did is created for us a REST template that uses JTK's URL, HTTP URL connection under the hood. And by default, this mechanism gives us no timeout. So basically, we just connect to our remote socket and just wait for the data. And if the data doesn't arrive, we just wait a little bit more. So probably this image scoring service, probably one instance got unavailable, maybe for a moment, and all our threads became blocked, just waiting for this data. So if our image scoring service was unavailable just for a moment, then restarting our instances actually would work, because we would free the threads and then we could process again. But it's more probable that our image scoring service basically got unavailable for a longer time. Perhaps there's some problem with network. So actually restarting the application wouldn't give us much, because yeah, we would just block again. So the solution's pretty simple. We just have to make our configuration a bit more complex. We need to set up our request factory with timeouts. Let's provide some arbitrary timeout, like 400 milliseconds. So this getting this number right is quite important. So if you monitor your dependencies, these services that you call, then you should know like what were the response times from the last week, from last month. So maybe you know what timeout to provide, or maybe you can talk with the authors of this service. What's their SLA? To get these values right. All right. But actually, okay, setting this will deploying this service will solve the problem. We will no longer wait indefinitely for data. At least if it's not a slow responding client, like giving us data just every 300 milliseconds, like bit for bit. In reality, we should probably change the request factory that we have here from a simple request factory to something more complex, like based on Apache HTTP client, because we probably need connection pools, which we don't have here. All right, longer term. How do we solve this problem once and for all in our project? Because every now and then somebody will create new REST template and forgetting about setting these timeouts. So what we can do is, for example, if we have our Spring Boot app, we can provide a REST template customizer into our context, and it's it's a class that it's an object that will be called whenever a REST template is added to context, so that we can customize the configuration. So we can customize our timeouts for every REST template created in the context. Or maybe we can create our own custom factory and just tell everybody in the company, hey, use this factory instead of saying new REST template, because the defaults are not right. Or perhaps just switch to using better REST clients. Better, I mean, with more reasonable defaults. So like OKHTTP, which I believe has a default of like 10 seconds. So for sure, 10 seconds is not the right timeout for our application. For sure, we need to tune it, but it's still, if we forget about it, it's still better than infinite. What are the takeaways? What do we learn from the freeze? First of all, we need to notice our integration points. So whenever we talk with some different service, or maybe a database, or maybe a message queue, we need to note what wrong can happen, like no data arriving, or just the service becoming unavailable, or maybe responding with some garbage data. So all these things. So I think a lot of people are saying about timeouts when in the context of HTTP clients, but we have more tools to think about, like maybe our database clients, database drivers. What's the timeout when you are connecting to Elasticsearch, for example, or when you are putting a message to Kafka? What's the timeout? How long will you wait for Kafka to respond? So these are important things to have in mind. Second thing, care for threads. Well, threads are a limited resource, so at least we have HTTP threads, and basically, if we block all of them, the application becomes unresponsive, and you cannot even make some debugging request to your application because all the threads are busy. So we need to care for our limited resources. And thirdly, test failure scenarios. We have a lot of ways doing that. We can use wiremock in our tests inside our application in integration tests, where we can stub our dependencies and inject some faults, like delaying the response or responding with some garbage, things like that. And then we can check in integration tests what happens. If there is a long delay, do we block? Do we get some exception that we don't handle and we respond 500 internal server error to our clients, or do we handle it gracefully and do something better? Second tool that I want to mention is ToxiProxy. It's a process that you can run on your machine or maybe on your laptop. It's a separate process that is acting as a proxy to, for example, to your external service. And what you can do is you can speak to your proxy instead of your service, and then this proxy allows you to inject some faults using a simple command line interface. So we can, for example, add fault that it's delaying the response for 10 seconds, or maybe that it's closing the socket suddenly, and things like that. You can check all the weird scenarios that for sure will happen one day in production. Okay, second thing I want to talk about, the arm. So let's go back to our controller, and this is how it looks like right now. There is a optimization that we can do here. Like what we're doing right now is we're having our offer, right? We are processing it, and only after this processing is finished, we respond to our caller that it's okay that we process the offer. So if the caller is interested in knowing if we managed to process this offer or not, then it makes sense, because he can get response to 100, and then he knows that it was indeed processed. But in our application, if there's some problem with processing some offer, like there was an error in processing and we didn't process it, well, actually we have so many offers in our system that if we don't process one, even if it was attractive, I mean, okay, it won't show on the showcase, no problem. So our caller doesn't care if this offer indeed managed to get processed or not. So what he would like to is that he sends us this offer and he immediately gets the response, like accepted, because he doesn't care if we process it or not, so he doesn't want to wait for us to do it. So we're going to do things asynchronously here, and we're going to submit processing tasks to our offer processor and immediately get the accepted response. So we want this processing, this offer processor process method to be executed asynchronously. So we can do it pretty easily in Spring Boot, just enable async. And then in offer processor, we say async. And now whenever we call process, it's actually being executed on some task executor. One problem with that is that by default, this task executor is not a threadful task executor, is an implementation of a task executor that spawns new thread each time you submit a task, you call this process method. So it's not something we would like to spawn new threads all the time because it's a simple way of breaking in production. So we want to limit this thread pool, right? Have like implementation based on thread pools. So thread pool task executor with a pool size of 10. So let's say we have 10 threads that are going to process our offers. And yeah, since we have it in our context, then all our async annotated methods are going to be executed on this task executor. So again, we run smoothly in production for weeks, and suddenly, again, our instance is not responding. We get an alert from somewhere. And it's very unfortunate because it's today that marketing made some fancy campaign, and there should be a lot of people trying to get to our site and create offers. And why today we have to break? It's very unfortunate. And soon enough, we get second alert that the second instance is also down. So it's a large problem. So quickly, let's go to the machine and check what's happening. We get the logs. Ooh, out of memory error. Okay. So what happened? So every time we get an out of memory error, basically what we want to do is check what was in the heap that caused this out of memory error. What's so large in our memory that it caused our memory to saturate? So one way we can do it is we can make a heap dump using JMap tool, and then having this large heap dump, large file containing what we have in our memory, read it in some GUI tool like JVisual VM or JProfiler, and just browse what do we have in our memory and what's taking so much space. But here, to make things simpler, I'm going to use command line tools. So once again, we get the process ID, and then we call jmap Histolife. It means get a histogram of all my objects in my heap, live objects, and check what is there. It's going to be ordered by how much space these are taking. So yeah, this is going to be a large output, so I'm going to just take the first 15 lines. And what we get here is a nice listing of all the classes and how many instances do we have and how many bytes are this taking. So we see that this application had like 256 megabytes of heap assigned. So we see that 171 megabytes, so almost all the space is taken by car arrays. So probably these are some strings, because we see that we also have a lot of strings. And when we highlight, we want to see our class, what's there for us. So we see that we have our offers, and we have the almost 20,000 offers in our memory. How is that possible if we are just, having 10 threads in our thread pool? Like 20,000, it seems a lot. So let's see how a Fletful executor works. So basically, we have 10 threads. Whenever a new task appears to be executed, it gets assigned to the first free thread. So it's assigned to the first thread. Then we get a second task, second offer to process. Since the first thread is busy, it gets assigned the second thread. And then next tasks get assigned further threads. And what happens when we get an offer right now and all the threads are busy? So a Fletful task executor, and actually that's how I would say by default that's how Fletful executors work. Is they have a queue of waiting tasks. So whenever a new offer comes and threads are busy, we just append it to this queue. And we append and we append. So if we have more load than we can process, then basically we are going to grow our queue indefinitely because it's unlimited by default. Well, actually, it's not unlimited. Under the hood, we have a linked blocking queue, so the maximum size is integer max value. But let's say, integer max value is basically effectively unlimited. But it's not true that it's unlimited, because everything has some limits, because we live in a physical world. In the physical world, everything has its limits. So there's no such thing as unlimited. Memory is our limit. So basically, we are just accepting work until we break, because we cannot get any more. So what we could do here, we could maybe increase the memory size. Maybe it's the first thing that comes to mind, but it doesn't solve the problem. It would just make the queue larger and make us break sometime later. So what can we do instead? How to get it working like right now? So maybe we can spawn more instances. We have only 2 instances, and we see that we cannot keep up with our work. So maybe spawning new instances is a good idea. Maybe increasing the pool size. We have a pool size of 10. Maybe it's not enough. Maybe we should have a larger pool size to be able to process more offers simultaneously. And here it largely depends on what is the bottleneck here. Because we don't know what's the problem. What's not keeping up with this load? Perhaps the database is slow because it cannot save things that fast. Perhaps this image scoring service is not responding in time because it got more traffic to process, and maybe processing these images takes a long time. Or maybe it's a problem with us. Maybe the database and the image scoring service are doing fine, and it's a problem with us not being able to create so many connections using only this small thread pools. So depending on what we see in the metrics, in the response times of database, of image scoring service, we can decide what to do. Because if we are the bottleneck, if the problem is that we cannot open enough connections, then spawning more instances or reconfiguring our application so that the pool size is larger is going to solve the problem, and we don't need to recompile our code and release a new version. But if the problem is with our dependencies, like this image scoring service, perhaps it's not keeping up with the work, well, just spawning new instances will basically just kill the image scoring service, because, if we open more connections, then we don't solve the problem of that service not responding in time. So it depends what we see in the metrics. And one more thing I want to highlight here is a problem that we often see when we have applications out of memory erroring in our environments. The problem is that if we want to, for example, restart our application, like restart all these instances at once, or maybe spawning new instances. The problem is that if you have this large traffic going into your application and you just spawn a new instance, it's suddenly going to get all the load that is going to your application is going to get to this one instance that is up. So if there is a problem with handling this large load, then probably you'll get a very quick out-of-memory error because you have this queue, right? And all the offers are going to get into this queue. So you will have a situation where one instance is up, it's getting killed. Then just sometime later, a second instance got up, but it's also getting killed. So they are getting killed all the time. So what you need here is some way to stop the traffic, get everything up, and then you can go with the traffic and serve the requests. So if one node is not enough to serve all the requests, you need to be able to somehow get the environment running. And then sending the traffic. And maybe we can. So with the problem, if the problem is with image scoring service and database, we need to solve the issue that is affecting us directly. We need to simply stop accepting work if we know we cannot handle it. I mean, what's the point in accepting new offers if you know that you have a lag of 20,000 offers waiting in your queue? So yeah, it's quite simple. In Fletful executor, we set the queue capacity. So let's say that we can process 200 offers, okay? And then whenever a new offer comes and the queue is full, it's going to get dropped, and we can survive and keep making progress with the offers that we have. Getting this number right, this queue size, is pretty important, and it's not that easy, again, because if you make this number too small, so if your queue sizes are small, then of course you won't be taking too much memory. But then, whenever you have a sudden burst of a large number of requests, you will have no way of amortizing that, and you will drop the offers, even though you could process them in 5 seconds later. So we will have no the buffer. But if you make the queue size too large, of course it must be a number that can fit in your memory. But even if it fits in your memory, if this queue size is large and it gets filled, you get to a point whenever a new offer comes to this queue, it's actually, by the time it gets to the beginning of the queue and you can process it, probably the caller will no longer, basically he will time out. He will no longer be able to read the data because he will basically give up earlier. So the problem that we may have with asynchronous processing and large queues is that when the load is large, we're not making any progress. So despite processing all the time, we're not making any progress because the caller waiting for our response is basically just timeouting before he gets the response. So sometimes, basically taking this number, having this number right is essential so that we can make progress and not just be busy processing tasks that nobody cares about anymore. So what we can do in the long term, so basically monitor the thread pools. We would like to know at least 2 things. So what is the threads utilization, how many threads in the thread pool are busy right now? So are all the threads busy all the time, or maybe just half of them? If all the threads are busy, then probably we're not keeping up with the work. And monitoring the queue size. That's also very important to be able to know when we get more load that we are able to successfully process. And for sure, we want to know and get alerted whenever our queue is full. And yeah, ensuring queue limits. So queues are in multiple places in thread pools, but also in some, yeah, basically they're throughout an application. It's important to know where they are, so we know where to limit them. Because often the queues that the thread pools, the queues that we build are not bound in size. So for example, if we create thread pool using executors, new fixed thread pool, then basically what we get is the same implementation on the hood, the same linked blocking queue, which is effectively unlimited. So using this is pretty dangerous. So what you would like to do instead, if you want to make a executor from JDK, well, use the new thread pool executor constructor that is used under the hood, this factory method, and then you can provide your implementation of the queue, like array blocking queue with a given capacity. So yeah, and the third thing I want to say about the ARM failure is load testing. So what we want to do is we want to check what's happening when we get more load that we expected. So first, whenever we make our load tests, we need to ensure that they are lengthy. They are taking a long time, like half an hour, or even more, so that we can give the opportunity for our queues to get full. All the problems that are appearing only after the application is handling the load for a long time, that we want to be able to see these problems that are not like instantaneously happening. And basically load tests, we need to ensure that they meet the SLA, so the response times are like they are expected. So it's not enough that we can accept the work, but also that we respond in time and that the responses are correct. So, for example, in our application, if we would do our load tests, we would like to check that indeed we stored all the offers that we wanted. It's not like they are waiting in some queue to get processed. So during load tests, we want to monitor our queues and see if there is some work like lagging, if there is some work like piling up and not getting processed because it's going to blow up like an hour later. And the second thing is what I called here 10x load tests. So basically checking what happens with your application when you get some ridiculous amount of load, like way more load that you expect in your production. So the idea is that your application should degrade gracefully. So so probably you would like to still be processing offers, but just rejecting the ones that you are not able to process anymore. But being alive and making some progress, the progress that you can make. What you don't want to do is have your application just dying, because that's too much. So it's worth checking these failure scenarios, because sooner or later you will get this more load. Like maybe you will have this problem that only one instance will be alive, and you will get more load that you expected on a single node. Or maybe the marketing department will do some awesome campaign, and suddenly your load will spike like crazy. And so the idea is that we want to make progress, even though we have large load. We cannot like sustain this load. We cannot process everything. We want to be able to process something. And a bit more on thread pools. Something we also saw, like what I call domino effect. So let's say we have a new feature. It's doing some unimportant stuff in some other component, and processing offers is the important thing in our application. And they are both processed asynchronously. So the problem is that these are going to be processed on the same task executor, because by doing at async, we say executed on the default executor that you have in your context. So what we have here is, let's say this blue star is this unimportant task, and this black one is processing our offers, the important thing. So in a in a normal situation, we have these tasks being executed on the same thread pool simultaneously, and it's not a problem. But let's say there is some issue with the blue task. There's an important task. Maybe it's starting to take very long because there's some problem with the database it's accessing, or maybe it just we have a lot of more requests about this unimportant task. So what we end up having is these unimportant tasks taking all the queue, all the threads, and actually queuing in the shared queue. And these important things are starved. They cannot get access to the thread pool. So basically, we have this inversion of priorities, like the unimportant stuff is getting progress, and this important thing cannot do anything. So what we want to do is separate our thread pools. So we want to make sure that our offer processing is executed on its own isolated executor, and nobody's going to take its threads. And then the unimportant thing has its own executor, or maybe multiple unimportant things have this shared executor, but basically we want to isolate the critical part. So right now, even though we have problems with our unimportant task, the offers, the important things, can get processed, and indeed there is nothing wrong. So what do we get from here? We should know where our pools are, where our queues are. So we know what to monitor, we know what to limit, and we know where application can go wrong. So it's extremely important, like right now when we are going asynchronous, reactive, all these nice things. We see hello worlds on the conferences and everything is running smoothly. But under the hood, there is some thread pool, there is some queue, and we need to understand the flow. We need to understand what's under the hood to be able to ensure that we are running smoothly in production. And actually, in this room, after my talk, there will be a talk from my colleague about HTTP servers and how they work under the hood. I think it may be very interesting. So I invite you there. Second thing, monitoring. Well, basically monitoring our polls, monitoring our queues, limiting them. So just knowing what's happening in our application. And isolating crucial parts. So, like I said, thread pools, being sure that your important tasks can make progress even though we have problems with some unimportant parts. But also things like maybe HTTP clients, maybe sharing your HTTP client among multiple. Maybe let's say we connect with various services, like maybe 3 services, image scoring service and some 2 others, and sharing this HTTP client for all of them. It may be a problem because maybe it's going to fill our connection pool some unimportant service, right? So we want to have isolated HTTP clients, maybe even isolated connection pools to our database if we have something very important that we need to ensure that it can get saved even though some other part of our application is having problems. So things like that. And doing serious load testing. So as I said, doing lengthy tests, checking what's happening with our application when it gets a large amount of load, like way larger than we expect in production, and seeing how our application behaves. Because it's going to be tested like somewhere and sometime somewhere. Either it's going to be on our laptop, on our test environment, or it's going to be tested in our production. So if you're interested in more, there is more on our tech blog, allegro.tech. There is a series called CQK Top 10. It's about thread pools, caching, memory, garbage collection, and things we're probably going to extend this with more chapters. So I'll just wait for you for a moment to be able to make a photo, and that's basically all I wanted to show you. We have time for questions. Any questions? Yeah. What's good?
Did you monitor your services? Which tools did you use for monitoring?
For monitoring? Okay, so at Allegro, what we're using is Graphite for storing our metrics. So what we do is every instance is collecting metrics using Drop Wizard metrics. So Drop Wizard metrics is a library that allows you to store metrics in your application. And then every minute we send the metrics that we gathered to our centralized storage, which basically keeps metrics from all the instances in our production. And there are also tools which work the other way around. So there's also a tool, I think it's called Prometheus, that basically it's a service that calls your instances and it pulls the data from your instances, taking the metrics. But gathering the metrics in your application, I can suggest Drop Wizard metrics. That's how it's called. Any more questions? Right. So thanks.